We have Sonny here. He's going to help us work through the problem of the week. So the problem says that we are allowed to pick a natural number, k, and we are going to define any linear function with k inputs, all natural numbers, and one output, natural number. And we're going to define a function that maps naturals to naturals in the following manner. The first k values for the function we get to pick to be any natural numbers we want. After that, the function is recursively defined in this manner. You take the previous k values that f gave you, you plug them into h, and then that will give you your next value for f. The question is to prove that this sequence is periodic. This symbol mod 10 means we're only considering the last digit. So in essence, the question is to show that the last digits of these numbers eventually start to repeat. All right, so we're going to work through an example, right? So give us a k value. K equals 2, which means h is going to have to take in two inputs, right? So let's define an h function. Well, we need h of x, y, right? The equal sign, let's get rid of that guy, great. Equals. And we want some linear function, so that's going to be adding up multiples of the variables. Sonny is picking one copy of x plus two copies of y. So linear means you can add together any number of copies of things, but you can't multiply them, you can't square, you can't do any weird stuff. Okay, and now we need to pick two values for, we need to pick our f of 1 to be anything. He's going to pick 5. Pick our f of 2 to be anything. He's going to pick 2. And at this point, everything is going to be recursively defined. So let's do f of 3. And let's go ahead and write out what that looks like with the h stuff here. It'd be h of f of 1. Oh, actually I made a mistake. That says n minus 1. Sorry, so that's going to be f of 2, comma, f of 1. Very good. Let's fill those in. So h of 2, comma, f of 2 is going to be 2. F of 1 is going to be 5. Okay, and then we're going to plug it into our definition there. 2 plus 5 times 2 is going to get us 12. Great. So what this h function essentially does is it takes a value and it adds it to two copies of the previous value, right? So that's what this guy's doing. So now let's do f of 4. So a 12 plus two 2's is going to get us 16. F of 5. 16 plus two 2's, so it's going to be 16 plus 24 is 40. I agree. Even the best of us make mistakes sometimes. How about f of 6? F of 6 is going to be a 40 plus two 16's, right? So that's going to get us 72 by my count. F of 7. 72 plus two 40's. Great. That's 152. Let's do one more.
152 plus 2 times 72.
Yep, and that's 144, so 286, I think. Sorry, so 152 plus 144. I get 296. I get 296. Yeah, I think actually we needed one more, don't we? F of 9. We picked this example ahead of time because it comes out very nicely. Plus 2 copies of 152. That winds up being 304, right? 600. Great. So now, this is the ultimate question. The AN sequence is derived by looking at the last digits. So there's a 5. For the first one, last digit of this next one is a 2. Last digit of the next one, oh, you want to write it all the way down there by the 12, I think. 2. Last digit down here is a 6. Last digit down here is a 0. last digit here. It's a 2, last digit here. A 2, last digit here. A 6, last digit here. A 0. And what do we get as our pattern here? 5, 2, 2, 6, 0, 2, 2, 6, 0. So the 2, 2, 6, 0 is repeating, and it will keep repeating. And it does not matter what linear function you use. It doesn't matter what your k value is to start with. It doesn't matter how you define these starting values for f. You will always wind up with a repeating pattern, and the question is why? First person to send me a solution wins the prize.